Have you noticed that modern engines with impressive fuel economy numbers are developing expensive problems way before they should? There's a pattern emerging that mechanics have been warning about for years. The combination of ultra-thin 0W-20 oil and gasoline direct injection technology is creating maintenance issues that older engines never experienced. After working on hundreds of GDI engines and seeing the damage patterns firsthand, I need to explain what's really happening under your hood and what you can do about it before you face a $4,000 repair bill. This isn't fear-mongering, it's documented science backed by thousands of field reports. Let's break down exactly why these technologies are problematic and how to protect your engine. First, let's understand what gasoline direct injection actually is and why it causes problems. In traditional port fuel injection engines, fuel sprays into the intake port just upstream of the intake valve where it mixes with incoming air. During this process, fuel washes over the intake valves, removing oxidized fuel and dirt from intake air. This constant fuel bath keeps valves clean naturally. In GDI engines, fuel is injected at high pressure directly into the combustion chamber, bypassing the intake valves completely. The finely atomized fuel improves combustion quality, delivering more power and lower emissions. But there's a serious downside. Since fuel no longer reaches and cleans the intake valves, carbon deposits build up rapidly on valve surfaces. These deposits come from multiple sources. Oil vapor from the PCV system settles on intake valves and bakes into hard carbon from combustion heat. Unburned hydrocarbons from incomplete combustion get sucked back during the intake stroke and adhere to valve surfaces. Higher combustion temperatures in lean burn GDI engines cause oil particles to bake onto valves more readily. The result is thick carbon deposits that accumulate surprisingly fast. Industry testing shows GDI systems are showing drivability issues related to carbon buildup on intake valves as early as 3,000 miles, causing hard starting and random misfire codes. Since fuel is not sprayed on the backside of the intake valves where fuel detergents can do their job, deposits build quickly. The carbon creates turbulence and restricts airflow into cylinders, causing performance problems like hesitation, stumbling, misfiring, and even hard starting. The thicker the carbon deposits on valves, the worse the drivability problems become. I've personally inspected GDI engines with just 30,000 miles showing significant carbon accumulation. By 60,000 to 80,000 miles, some engines have deposits thick enough to cause noticeable power loss and fuel economy reduction. In extreme cases at 100,000 miles, I've seen carbon buildup so severe that valves couldn't seal properly, causing compression loss and complete engine failure. This wasn't a problem with older port injection engines because fuel constantly cleaned the valves during normal operation. Now let's talk about how 0W-20 oil makes this problem worse. Low viscosity oils like 0W-20 were mandated by automakers primarily for fuel economy. Thinner oil reduces internal friction, which improves EPA test numbers and helps manufacturers meet CAFE standards. But there's a mechanical trade-off. Research indicates that low-viscosity motor oils such as 5W20 and 0W-20 make carbon deposit problems worse because they are thinner to reduce friction and flow more easily down valve guides. When thin oil seeps past intake valve guide seals and reaches hot valve surfaces, it vaporizes more readily than thicker oils, contributing to carbon formation. Here's what actually happens. All engines allow small amounts of oil past valve guide seals for lubrication. With thicker traditional oils like 5W30 or 10W30, less oil migrates down guides because of higher viscosity. The oil that does reach valve stems tends to stay liquid longer and drains back rather than baking onto hot surfaces. With 0W20, the ultra-thin viscosity allows more oil to flow past seals. That oil reaches the hot valve surface and immediately vaporizes or burns, leaving carbon residue that accumulates over time. Additionally, 0W-20 oil has lower high-temperature viscosity than traditional grades. At the extreme temperatures inside GDI combustion chambers, which can exceed 2000 degrees Fahrenheit, 0W-20 provides a thinner protective film. Oil that makes it onto piston tops or valve surfaces has less resistance to vaporization, contributing more to deposit formation than thicker oils would under identical conditions. The PCV system also plays a role. Positive crankcase ventilation routes oil vapors back into the intake manifold to control emissions. In older port injection engines, these vapors mixed with fuel spray and burned cleanly. In GDI engines, those same oil vapors settle directly onto intake valves with no fuel to wash them away. The combination of thinner 0W-20 oil creating more vapor and GDI design providing no cleaning mechanism creates accelerated carbon accumulation. Here's real-world data. Multiple manufacturers now acknowledge this problem and some have implemented solutions. Toyota developed dual injection systems combining both port and direct injection specifically to use port injection's cleaning action on intake valves while maintaining GDI's efficiency benefits. Some Lexus models use both direct injection and intake manifold injectors, with intake injectors turning on periodically to wash valve backsides. Honda modified some GDI designs so injector spray intentionally hits the edge of intake valves to provide minimal cleaning. These engineering changes prove manufacturers recognize the problem. They wouldn't invest in dual injection systems if carbon buildup wasn't a legitimate concern affecting engine longevity and customer satisfaction. The fact that newer engines are being redesigned to reintroduce fuel contact with valves demonstrates that pure GDI has fundamental maintenance challenges. So what does this mean for you as an owner? If you have a GDI engine, especially one using 0W-20 oil, carbon buildup is inevitable, not a possibility. The question isn't whether it will happen but how fast and how severe. Driving conditions dramatically affect accumulation rate. Short trips where engines don't reach full operating temperature accelerate buildup. Stop-and-go city driving creates more incomplete combustion and unburned hydrocarbons. Engines that idle frequently allow more time for oil vapors to settle on valves. Highway driving actually helps minimize deposits because sustained high-temperature operation tends to burn off lighter accumulations. But even with ideal highway use, carbon still forms over time because the fundamental problem remains. Oil vapor from the PCV system has nowhere to go except onto intake valves, and no fuel washes them clean. The typical service interval for GDI carbon cleaning is every 20,000 to 40,000 miles depending on driving conditions. This involves removing the intake manifold and walnut blasting the valves, a procedure that typically costs $400 to $800 at independent shops and up to $1,200 at dealerships. Some shops offer chemical cleaning through the intake manifold, which is less expensive at $150 to $300 but less thorough than walnut blasting. For severely neglected engines at 100,000 miles with no cleaning history, the carbon can be so hardened that even walnut blasting struggles to remove it completely. Here's what you can do to minimize the problem. First, use top-tier certified gasoline exclusively. While detergents in top-tier fuel don't directly reach intake valves in GDI engines, they do help keep injectors and combustion chambers cleaner, which reduces the source material for carbon formation. Second, follow strict oil change intervals using oils meeting APISP or ILSAC GF6 specifications. These newer oil formulations were specifically redesigned in 2020 to reduce deposit formation in GDI engines. Don't extend oil changes beyond 5,000 miles even if your manual allows longer intervals. Third, consider using quality fuel system cleaners designed for GDI engines every 3,000 to 5,000 miles. Products like CRC GDI Intake Valve Cleaner or BG Gasoline Direct Injection Cleaner can be sprayed directly into the throttle body to treat valves. While not as effective as physical cleaning, they provide some maintenance benefit between major services. Fourth, avoid excessive idling and short trips when possible. Highway driving helps keep everything hotter and cleaner. Fifth, some owners install oil catch cans on the PCV system to trap oil vapor before it reaches the intake manifold. This aftermarket modification can significantly reduce carbon accumulation by preventing oil vapor from ever contacting intake valves. Quality catch can systems cost $100 to $300 installed and require periodic draining, but they address the root cause rather than just treating symptoms. Now about 0W-20 specifically. If your engine was designed for it, you must use it for warranty compliance and proper operation. Modern engines with variable valve timing and tight tolerances require exact oil viscosity for proper function. Using thicker oil will cause problems with VVT systems and oil flow. However, understanding that 0W-20 contributes to carbon formation helps you make informed maintenance decisions. You know you'll need more frequent carbon cleaning services compared to older engines using thicker oils. Budget for this maintenance rather than being surprised by it. For high-mileage GDI engines over 100,000 miles showing oil consumption or using oil, switching to high-mileage 0W-20 formulation with seal conditioners may help reduce oil seepage past valve guides, potentially slowing carbon accumulation slightly. But this is marginal benefit, not a cure. The bottom line is this. Modern GDI engines with 0W-20 oil deliver impressive fuel economy and low emissions, but they require more intensive maintenance than older designs. Carbon buildup on intake valves is not a defect, it's an inherent characteristic of this technology. Manufacturers chose fuel economy over long-term serviceability because CAFE regulations forced their hand. They're selling you efficiency today in exchange for maintenance costs tomorrow. This doesn't mean GDI engines are bad or that you should avoid them. Most modern vehicles use this technology and it's not going away. But you need to understand what you're dealing with. Plan for carbon cleaning every 30,000 to 50,000 miles as regular maintenance, not unexpected repair. Use quality fuel and oil. Don't extend service intervals. Consider a catch can if you plan to keep the vehicle long-term. These steps won't eliminate carbon formation, but they'll minimize it and prevent the severe buildup that causes expensive engine damage. If this information just saved you from unexpected repair costs or helped you understand why your GDI engine isn't running as smoothly as it used to, hit that like button. Drop a comment telling me what GDI vehicle you own, current mileage, and whether you've experienced carbon-related issues. And if you want more honest talk about modern engine technology and how to maintain it properly, subscribe to this channel. Next week I'm revealing the truth about extended oil change intervals in GDI engines and why following manufacturer recommendations might be costing you thousands in premature wear. Subscribe so you don't miss it. Remember, understanding your engine's weaknesses is the first step to protecting it from expensive failure.